Now coming to the new inventions in cartographic methods. Since the mid-1900, technologies have helped professional cartography undergo rapidly accelerating change. Photolithography and photo engraving have merged photography with printing. High-speed multicolor lithographic offset process can rapidly produce maps of almost any degree of detail, color scheme or labeling requirement. Technology known as remote sensing has also enabled modern cartographers to chart the depth of the ocean or the frontiers of outer space. The space program has taken cameras into orbit, providing vast image collections of Earth, other planets and even other galaxies. Equally far-reaching advances in cartography have emerged from advances in electronic communication and various computer applications. Modern computers can store and transmit huge amounts of mapping data and then control the assembly of such data, producing maps using sophisticated digitizers, plotting mechanics and electronic typography. Information gathering technology has produced advanced cameras that can transmit digital data from outer space and maps which show nearly any place or geographic theme for which digital information can be retrieved. Geographic information systems are the most recent synthesis of these modern technologies. The current systems used for GPS is administered by the United States, although the European Space Agency has plans for a similar system. Because of military security concern, the US government regulates the resolution of satellite transmissions available to the public for GPS use. Although GPS units are theoretically accurate to within several centimeters, their practical range today is about 3 to 30 meters, not accurate enough for collecting precise map data. Another problem with using GPS to collect map data is that trees and steep terrain block the reception of satellite transmissions. The most common and rapidly growing use of GPS is in aircrafts and ship navigation, and some vehicle manufacturers are beginning to install GPS in their cars. In Oslo, Norway, a taxi company is installing GPS in all its taxis to help track individual cars and provide security oversight for its drivers. Remote sensing is used to reveal obscure or misunderstood phenomena. An example is the recent detection of the lost city of Ubar in Oman, which was rediscovered with the help of NASA satellite radar imagery. Image analysts used cartographic methods to pick out clues from the radar images, including caravana tracks that pointed them to the buried city ruins. Most maps and atlases use data from remote sensing sources to create some of its maps. Remote sensing sources used in these maps include spot satellite images of cities, Earth by day and Earth by night composite satellite images, and hypsography or terrain and elevation data for the entire world. The ecoregions data in Encarta World Atlas is the combination of remotely sensed vegetation, land cover and climate data composed in a GIS setting. Finally, coming to conclusion. Aerial photographs and satellite images portray only certain portions of the light spectrum as filtered through the atmosphere and detection instruments. A map can display only a few selected features which are portrayed usually in highly symbolic styles according to some kind of classification scheme. In these ways, all maps are estimations, generalizations and interpretations of true geographic conditions. Finally, any map is the product of human endeavor and as such may be subject to unwitting errors, misrepresentation, bias or outright fraud. In spite of these limitations, maps have proven to be remarkably adaptable and useful through several millennia of human civilization. Maps of all kinds are fundamentally important for modern society. So students, thank you for watching this episode. Hope we will meet in future episode. Till then, take care. Thank you.